Hello, this is Mr. Sullivan, and today we're going to look at factoring, which is the same thing as undoing the distributive property. So let's look again at the distributive property, and let's use a different model to show how the distributive property works. Let's imagine a rectangle, and this rectangle, right, has a length and a width, and to get the area of a rectangle, you multiply. So we'll call the width of the rectangle, okay, x plus 3, meaning that this portion of the width is an unknown value x, and this portion of the width is a positive 3, a distance of positive 3. Then this will be our length, meaning this has the same unknown length x, and this has a length of 5, or in this case positive 5. So now our rectangle has dimensions x plus 3 by x plus 5. So to show how the area of this works, we'll look at each portion of this bigger rectangle. This piece right here is a square, and its area is x times x, which is x squared. This area right here is a length of x, an unknown length of x, by 5. So the area would be 5 times x, or 5x. This rectangle right here has a length of 3 by x. This distance again is the same as this distance, so it's x, so we have 3x. And now the final little piece right here, this rectangle right here, has a width of 3 and a length of 5. So its area would be 15. You actually, since I made this 3 by 5, you can count 15 squares. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So there's 15. 5 plus 5 plus 5. Now if I wanted the area of this bigger rectangle, all I have to do is add up all these parts. So this piece is x squared. These two pieces together, this one and this one, would be 8x. So it's plus 8x. And this piece is 15. So this expression, we call this a trinomial because it has 1, 2, 3 terms. This trinomial represents the area of the whole rectangle. It works even with negative lengths. Even though in the real world we don't have negative lengths, the model is still useful. So the length here would be x, and then this piece would be plus 7. So the whole length of your rectangle is x plus 7, and this would also be x, but we now have a minus 3 here. So now the rectangle has an area of x plus 7 times x minus 3. So this piece is x squared, and this piece has dimensions x times 7, so that would be 7x. Now this piece is going to give us a negative answer, so why don't we just make this little piece right here red to show that it's negative. And we get an area here of negative 3x, because we're doing negative 3 times x. And now this piece is also going to be negative, because I have a negative 3 times a positive 7. So this piece will also be red. And we get an area here of negative 21. Now the whole area is going to be all of these pieces added up. X squared. Now this 7x minus 3x will give us a plus 4x. And since we have a negative 21 here, we're going to subtract 21. So if you notice, these two answers here, these two trinomials, are very similar to this trinomial right here. And we got them by multiplying two binomials, two expressions with two terms. So to factor, I'm just going to go from here, from a trinomial, back to the two binomials that were multiplied together. So one way to do it is to build a nice model, right? Again, we're using our pretend x by x square to get us that first term in the trinomial, which is x squared. Now we have some piece where we have to figure out the area of this piece, the area of this piece, and the area of this piece, right? So if I look back at these examples, I see this was 15, and that represented this area. this negative 21 represented this area. So I know right off the bat that this piece is 12, and I know that this piece is x squared, just by looking at these two terms. Now the question is, how do we figure out the middle term? It's going to be this piece plus this piece. So I'm looking to figure out what the dimensions of my rectangle were that gave me this trinomial. So the other piece of information I know is that these two numbers that multiply to 15 also add together to give me this middle term. So let's think about what numbers multiply to 12. 1 times 12, 2 times 6, 3 times 4. I also could do negative 1 times 12, because here we dealt with a negative, negative 2 times 6, and negative 3 times 4. So the next job is to figure out, well, what are the two areas over here, right? And we know that they have to add up to plus 7. So I look through my list and find a pair of numbers that add up to 7. And I look at 3 times 4, right? If I add 3 and 4, I would get 7. So let's see if it works, right? If I have a 4x and a 3x, I can see 4 plus 3 is 7. So that means that this piece right here must be a plus 4, and this piece right here must be a plus 3. So my original dimensions were x plus 4 times x plus 3. And what I did there was I factored, or I undid the distributive property. This one's a little bit more complicated. They want you to do an extra step. They're saying, okay, well, let's look at these. All these terms have something in common. They all are divisible by 3. So what you can do here is you can pull out the 3 and then just divide each term, or unmultiply each term, right, by 3. So if I do 3x squared divided by 3, I'll get just x squared. If I do 12x divided by 3, I'll get 4x. And if I do 9 divided by 3, I'll get 3. So you can see I unmultiplied, because 3 times x gives you 3x squared, 3 times 4x gives you 12x, and 3 times 3 gives you 9. And what you have to notice here is that, again, we have a trinomial. So I can go another step and I can factor this again. So using the same model, let's say this is x squared. And this has to have an area of 3. And now I just got to fill in these other two rectangles to make the whole area. So I'm thinking to myself, what numbers multiply together to give me 3? Well, I've got 1 times 3, or I've got negative 1 times negative 3. But I need them to add up to positive 4, so this works. So this will have to be my 3x, and this will be my 1x. So this must be x plus 3, and this must be x plus 1. So the factored expression would be x plus 3 times x plus 1. But don't forget, this whole piece, we just factored this section right here, and this whole piece needs to be multiplied by 3. So now we've factored this completely. That's just an introduction to factoring. And whenever you see an expression that looks like a trinomial, ask yourself, can it be factored into a binomial? Can I take this and make it look like that? Good luck.